Kansas City, an expanding urban area lying across the Missouri-Kansas boundary at the confluence of the Missouri and Kansas rivers. The skyline can look like this or like this. Recognition of the severity of air pollution in the Kansas City area led to investigations which resulted in federal abatement actions by the Department of Health, Education, and Welfare through its National Center for Air Pollution Control. Under authority of the Federal Clean Air Act, the National Center for Air Pollution Control can engage in air pollution abatement activities where there is evidence of interstate transport of airborne pollutants which may endanger the public health or welfare. An abatement activity was established in the Metropolitan Kansas City Area in cooperation with state and local agencies on May 23, 1966. The resulting technical investigation of air pollution has encompassed a 4-county area in Missouri and a 3-county area in Kansas, with a combined total of more than 3,200 square miles. Widely diverse in population density, in land use, in industrialization, and in total economic activity, the Kansas City area is the home of 1,300,000 persons. The abatement activity was initially concerned with visibility reductions caused by air pollution in the vicinities of the Kansas City Municipal and Fairfax airports. Concern regarding the visibility problem was voiced by the Federal Aviation Agency, aircraft pilots, and several other groups. Investigation of this specific problem was limited to an area surrounding the 2 airports and was confined to the survey of particulate pollutants, which are the primary cause of visibility reductions. In a January 1967 conference, representatives of the states of Missouri and Kansas, the health departments of Kansas City, Missouri and Kansas City, Kansas, and the National Center for Air Pollution Control presented findings of the airport area survey. The conferees agreed upon 4 recommendations: establishment of an interstate air pollution control agency, prohibition of open burning of refuse in the area around the airports by August 1, 1967, and in the greater Kansas City area by July 1, 1968. Control of emissions from 20 industrial sources cited at the conference, and restrictions on new sources of particulate emissions to be placed in operation within the metropolitan area. Control of emissions in the airport area alone would not eliminate the air pollution problem in Kansas City. Although a pollutant may have its most intense effect near its source, it may also be carried many miles from its original source, mixing with pollutants from other sources and contributing to a homogeneous mass of pollution which blankets the entire region. Following investigation of the airport visibility problem, technical studies of air pollution in the entire Kansas City area were initiated. This investigation demonstrated that air pollutants move freely across state boundaries. Assessments of sulfur dioxide, carbon monoxide, and hydrocarbon emissions, as well as particulate emissions, were included in the expanded survey. These pollutants emanate from 4 general categories of sources: refuse combustion, industrial processes, fuel combustion, and mobile sources. The first category of sources of air pollution, refuse combustion, contributes a large percentage of the total airborne particulates. Since open-burning dumps are so widely scattered throughout the area, no part is free from their effects. The dense billows of smoke produced during periods of extensive dumping are more than just nuisance. They can blot out the sunlight and carry tons of filth to be dropped on surrounding areas. Because of the non-uniformity in refuse composition and quantity, burning at the dump sites is usually sporadic. Burning is used primarily to achieve reductions in the volume of refuse by converting the combustible fraction into gaseous combustion products in the air, often creating an air pollution problem to replace the solids waste problem. 18 of these dumps burn sufficient refuse so that each spews more than 100 tons a year of particulates into the atmosphere. Salvage yards are other sites of uncontrolled open burning. Metal is recovered from old railroad cars in this operation. Auto salvage yards are scattered throughout the entire Kansas City area. Survey questionnaires revealed that at least 13,000 automobiles a year are burned to remove the non-metallic interior parts. On-site burning also makes a significant contribution to the pollution resulting from refuse combustion. Since the majority of residents in the survey area are not provided with municipal refuse collection, many dispose of their combustible trash by individual burning. Some industrial and commercial establishments dispose of their own waste products, often in incinerators. From the Air Pollution Authority's viewpoint, the uncontrolled teepee incinerator provides little improvement over open burning. Single-chamber refuse incinerators, most of them lacking air pollution control equipment, are widely used. There are no large municipal refuse incinerators in the Kansas City area. The Kansas City, Missouri sewage treatment plant uses incinerators to dispose of its dried sewage sludge. These multiple hearth incinerators are equipped with wet scrubbers for air pollution control. Land clearance, urban renewal projects, and highway construction account for isolated but sometimes large open burning sources. Better control of refuse combustion or development of alternate methods of refuse disposal should be sought to achieve a reduction in Kansas City's atmospheric burden of particulate material. The second category of air pollution sources, industrial processes, is responsible for almost 1/3 of the particulate emissions and for substantial amounts of the sulfur dioxide, hydrocarbons, and carbon monoxide. Kansas City has a number of steel and non-ferrous metal foundries. The foundries vary greatly in size and in type and efficiency of air pollution control equipment used. The foundries all have melting furnaces or cupolas. Installations which reprocess scrap metal may also have scrap preheaters, sweat furnaces, or other important sources of particulate emissions ahead of the metal melting and forming processes. Kansas City is the transportation hub of the Midwest farming region and has an abundance of grain mills and storage elevators. Air pollution problems at the granaries result mainly from grain losses during handling, drying, and milling operations. The size of dust particles emitted from granaries is relatively large, so it is not difficult to reduce the losses by installation of proper control equipment. In addition to the reduction in airborne pollution, use of air pollution control devices can result in product recovery. 2 large petroleum refineries are situated beside the Missouri River near the downtown area. The refining, reforming, and blending of the petroleum products and disposal of refining wastes result in emissions of particulates and many noxious gases, hydrocarbons, oxides of nitrogen, carbon monoxide, aldehydes, oxides of sulfur, and ammonia. Production and transfer of construction materials create locally severe air pollution. Rock quarrying and crushing operations can fill the air with rock dust unless control devices are installed on the crusher. Asphalt and concrete batching plants also have dust losses. The daily and seasonal variations in production rates cause peak discharges from these operations to be several times as great as the average annual rate of emission. Cement is manufactured at 2 locations in the Kansas City area. This process requires firing of the raw materials in a rotary kiln at temperatures in excess of 2,500 degrees Fahrenheit. The hot gases from the kiln, already heavily laden with dust from the cement forming reaction, are used to dry the incoming raw materials. Additional dust is entrained in the drying process. This plume from a cement plant extends for many miles downwind. The chemical industry is represented by a wide variety of significant sources scattered throughout greater Kansas City, including plants which produce acids, ammunition, pesticides, paints, fertilizers, glass fiber, and an operation which recovers chemicals from waste products. reduction of pollution from industrial processes will prove an important step in air quality conservation. The burning of fuel, the third category of air pollution sources, produces most of the area's atmospheric burden of sulfur dioxide. 5 industrial sources, 8 public utility power plants, and 3 governmental installations each produce more than 100 tons per year of pollutants from combustion of fuel. However, the thousands of homes and small businesses in greater Kansas City burn a significant portion of the fuels consumed in the area during the winter heating season. Fuel combustion and consequently the pollutant emissions from fuel combustion are subject to extreme seasonal variations. Because sulfur dioxide is a gas and does not form a visible plume, the public is often unaware of the damage it causes. Vegetation is readily damaged by sulfur dioxide. Sulfur dioxide also promotes atmospheric corrosion of stone, concrete, metals, and other construction materials, increasing maintenance and replacement costs. The fourth category of air pollution, mobile sources, includes emissions from all vehicles that are propelled by the combustion of fuels. Last year, more than 600 million gallons of gasoline and 90 million gallons of diesel fuel were consumed in the Kansas City area to provide power for motor vehicles, trains, and tugboats. Aircraft contribute to visibility problems at the airports by their own particulate emissions. Exhaust from motor vehicles has been blamed for air pollution problems in other metropolitan areas. However, in Kansas City, mobile sources account for a relatively small percentage of the air pollution problem. This may be further reduced by federal requirements for engine exhaust emission control devices on all 1968 and subsequent model passenger vehicles. So this is the problem. Hundreds of sources pouring out thousands of tons of pollutants into the same air that we must breathe. Now we can depend only on atmospheric conditions to disperse the contaminants high above the earth, or surface winds to carry the plumes away. But the weather is at best uncertain and hardly to be depended upon. Thermal inversions and calms can trap the contaminants, causing a sharp rise in pollution levels. If present conditions are a menace to the health and welfare of the community, what can the future bring? More offices, homes, and motor vehicles. Expanded industrial operations and increased demands on electrical power plants are a certainty. The usable air supply will not increase. Since we cannot depend on the weather, we must plan to abate air pollution at the sources. We must take all steps necessary to keep pollution out of the atmosphere.